Okay, now we're going to start talking about the asymptotes of a rational function, okay? So an asymptote is a line or curve that a graph gets closer and closer to. There are three types of asymptotes: vertical, horizontal, and oblique. Oblique asymptotes are also known as slant asymptotes. Okay, we are going to start off by talking about vertical asymptotes, and then we will discuss horizontal and oblique together. Okay, all right, so here we go. So let's look at the information under vertical asymptotes. Again, a vertical asymptote is just going to be a vertical line that your graph is getting closer and closer to, but never touches. Okay, so if we read under here, it says the graph of a rational function will never touch or cross a vertical asymptote. To find a vertical asymptote, okay, let's read the steps and then I'll elaborate a little bit. The first thing you want to do is get the function in lowest terms by factoring the numerator and the denominator and then canceling common factors. Then you're going to set the denominator equal to 0 and solve for x. And then in step 3, any real numbers obtained from step 2 will be vertical asymptotes of the graph in the form x equals a number from step 2. Okay? All right. So again, the big thing to know is what a vertical asymptote is and then how to calculate one given the equation of the function. Okay? Vertical asymptote. It is a vertical line, so up and down, that your graph gets closer and closer to, but never crosses or touches. Okay? So what you're basically going to do, and I want to make this clear, finding a vertical asymptote is very similar to finding the domain of a rational function, but it's a little bit different, and you need to know what that difference is. You are going to concentrate on finding the bad spots, okay? But not every bad spot is a vertical asymptote, okay? Let me say that one more time. You are going to concentrate on finding the bad spots, okay? If there is a vertical asymptote, it's going to happen at a bad spot, but not every bad spot is a vertical asymptote. Okay, I am going to write that down. Okay, vertical asymptotes occur at the bad spots. Okay, so where the denominator is 0. Okay, but not every bad spot is a vertical asymptote. Very important to understand that. And I will show you an exception. So just hang on. Okay. All right. So again, you need to be honing in on bad spots where the denominator is 0. Okay. So like I said, it's very similar to finding the domain. Okay. What you're going to do once you get your rational function, you are going to see if you can factor the numerator and factor the denominator. Okay. You may not be able to, but if you can factor either one, you should factor. Okay. Once you factor, you want to see if you can cancel any of the factors. Is there a factor in the top that cancels with one in the bottom? If there is, you should cancel. Okay. Sometimes you won't be able to do anything, and that's okay. Okay. But if you can factor and cancel, you should. Okay. So if you can factor and cancel, that is what you work with going forward. Once you have factored and canceled, then you take the bottom, set it equal to 0, and whatever that result is, that bad spot, that is where your vertical asymptote is going to live. Okay, so one more time before we do this. Okay, you're going to get your fraction. Okay, you're going to see, if possible, if you can factor the top and the bottom. Okay, one or both. Okay, if you can factor, you're going to see if there's any factors that you can cancel. Okay, if you can, go ahead and do that. Okay, whatever the result is, that's what you work with going forward. Okay, you take the denominator of that, set it to equal to 0, and whatever bad spot you get from there, that is going to be where your vertical asymptote is, okay? Now, another thing to remember, vertical asymptotes are vertical lines. So when you write them down, you have to write down their equations, okay? Their equation, if you think back to section 2.2 when we learned lines, the equation of a vertical line is x equals, okay? So that's how you're going to have to write down a vertical asymptote. You can't just give me the number. You have to say x equals the number, okay? All right, let's take a look at the first one, okay? All right, so in example 2, I give you 4 different rational functions, and it says to find the vertical asymptotes, if any, of the graph of each rational function, okay? Just because it's a fraction, that doesn't necessarily mean you're going to have a vertical asymptote, okay? All right, so look at the first one. Okay, f of x is equal to x plus 3 over x minus 1, okay? I'm going to look at the top, x plus 3. Can I factor that? Nope. I'm going to look at the bottom, x minus 1. Can I factor that? Nope. Okay. There is nothing you can cancel here. Okay. You cannot cancel the x's just because you have an x in the top and an x in the bottom. You can't cancel that. Okay. Again, let me be clear before we do this. Okay. When you can cancel, whoops, as opposed to when you cannot cancel. Okay. So when you can cancel. So an example would be like this. I'm making this up. This is not related to any of these 4 problems we're about to do. If I had, I'll use some of the same pieces you saw in part A. X plus 3 times x minus 1 over x plus 2 times x minus 1. Okay, so if I had something like this, okay, then I see clearly there is a factor, a package deal of x minus 1 in the top and an x minus 1 in the bottom package deal. I can cancel those, okay? But if you just have, see, you can't cancel these x's right here because this x is attached to the 3 and this x is married to the 1, okay? So you can only cancel in a situation, you can only cancel factors, okay, not individual pieces, okay? All right, so in part A, you can't factor the top, you can't factor the bottom, and that is okay. So you move on with what you have, okay? You're going to take the bottom, so it's equivalent to finding the bad spots, okay? So you're going to take the bottom, set it equal to 0, solve, okay? You're going to get x equals 1, okay? That is actually your vertical asymptote, okay? So the great thing about doing this is when you solve and you set the bottom equal to 0, it's reminding you that the equation of the vertical asymptote, not only does the asymptote occur at x equals 1, but it actually gives you the equation of the vertical asymptote. Okay, so for here, there is one vertical asymptote, oops, and the equation is x equals 1. Okay, now, another great thing about doing a problem like this, you can check yourself. You need to take this rational function and you need to plug it into the calculator and see if you have a vertical asymptote displayed at that particular x value, okay? So I'm going to go ahead and plug this rational function into my calculator, okay? We expect it to be at x equals 1, okay? I have an old school calculator, so I'm going to talk about that. You're going to go to y equals and you're going to type in the function. If you have an older calculator like me that doesn't display it all nice, you need to put the entire numerator in parentheses and the entire denominator. So in parentheses, I would have x plus 3 divided by, put the entire denominator in parentheses. So x minus 1, close parentheses. This is the way you should be entering it in, okay? If you have an older calculator like me and you do not put the parentheses, it is going to mess it up, okay? Again, my window, I'm going from -10 to 10 in both directions with a tick mark every 1 unit. Hit graph, okay? And this is what it looks like, okay? Okay, this is part of the graph. This little piece, as is this piece over here, okay? If you notice, and this happens only on an older calculator like mine, okay, if I count the tick marks, here at x equals 1, you have this vertical line. That is actually not part of the graph. That's the vertical asymptote, okay? If you have a newer calculator, it probably doesn't display the vertical asymptote. Okay, again, the asymptote's not part of the graph. And if you have an older calculator, it will show up like it's part of the graph, but it's really the vertical asymptote. But you can confirm that your vertical asymptote, this line that you're getting closer and closer to without touching or crossing, is happening at x equals 1. Okay, I do not expect you to graph something like this by hand at all. Okay, I just need you to be able to place where the asymptotes are, whether it's vertical, horizontal, or oblique. So you can check yourself on the calculator, but again, you do not have to graph this by hand. Okay, for your records, okay, because everybody's calculator is different, I went ahead and for all of these that we're going to do, I went ahead and I printed up the graphs so that you can refer back to them if you're studying. Okay, so all the vertical asymptotes for example 2 are found on page 4 of the notes. So this is example 2a. This is the graph. You can see it in color here, so that's a little nicer than what you were seeing on the calculator there. Again, based on what I used, I couldn't go from -10 to 10. I could only go from -6 to 6 in both directions, but you get the idea. So at 1, x equals 1, you're going to have the vertical line. Okay, I put it as a red dotted line. That's your vertical asymptote. And so what will happen if you could see more of this graph, this blue piece right here is actually going to get closer and closer and closer and closer to that red line, but never cross or touch it. And then in this direction, this blue piece will get closer and closer to the red line down here, but never cross or touch it. Okay, so you do have a vertical asymptote there at x equals 1. Okay, and again, seeing this answer, you can kind of interpret it in 2 different ways. The asymptote is occurring at the x value equals 1, but x equals 1 is also the equation of the vertical asymptote. Okay, all right, let's do the second one and then look at its graph. Okay, the second function in part B, r of x is equal to x over x squared minus 4. Okay, first thing we need to do is factor. Okay, so if I look at the top, the numerator is x. There's nothing you can do with that. So just leave it alone. But the bottom does factor. Okay, it's a difference of squares. Okay, regardless of whether you know that rule or not. But x squared breaks down into x times x. 4 breaks down into 2 and 2. And then the signs, so basically what I mean by difference of squares, the square root of x squared is x, the square root of 4 is 2. You're subtracting, that's what difference means. This does not work for addition. Okay, there's going to be one of each. Okay, a plus and a minus. It doesn't matter which one you write first. Okay, if you multiplied this back out, you would get x squared minus 4. So you would get x squared minus 2x, and then the minus 2x would cancel with the positive 2x, and then 2 times negative 2 is negative 4. Okay, so the bottom factors, the top does not. Okay, now you say, okay, well, can I cancel anything? Okay, well, there's nothing to cancel. Okay, because remember, this is a package deal. I would have to have another x plus 2 up here in order to cancel it. And I would have to have another x minus 2 up here in order to cancel. Okay, so you can't cancel here. So you can go straight to setting the bottom equal to 0 to solve for your bad spots. Okay, so in the next step, now we will take the bottom and set it equal to 0. Okay, again, you might think multiply it back out. If you multiply it back out, you're going to get x squared minus 4 on the left. Okay, that is quadratic. You need to factor or use the quadratic formula. It's already factored for you. We just did that. Okay, so there's no need to multiply it back out. You're going to take each factor, set it to 0, and solve. Okay, so here we're going to get one vertical asymptote at x equals negative 2, and then the other one is going to be at x equals positive 2. Okay, so I'll go ahead and write that down. Okay, so for this particular problem, the vertical asymptotes, there's 2 in this case. They're at x equals negative 2 and x equals positive 2. Okay, and remember, these are actually the equations of the asymptotes because you have to have x equals a number since it's a vertical line. Okay, so here we go. Again, You could plug and chug this into your calculator to see the picture, okay? I'm going to pull back the sheet because I graphed it for you and put it in the notes, okay? Here's the example 2B graph, okay? The blue part is actually the graph, and then the red dotted lines are the vertical asymptotes, okay? So you see there's one at x equals -2 and one at x equals +2, okay? This piece of the graph, you can see it's getting closer and closer to the red line down here. It does not cross or touch it if you zoomed out on the graph. Over here, this middle piece in between the two asymptotes, this part gets, if you go up, it gets closer and closer to the red dotted line, never crosses or touches it. Same thing down here, we're getting closer and closer to the red dotted line, but do not cross, do not touch. And then over here, you're getting closer and closer to this asymptote, but not crossing or touch it. Okay, so that's what the graph for example 2B looks like. Okay, all right, let's take a look at example